heading here when we're solving right triangles. Solving right triangles means finding missing side lengths, like how far up the wall our ladder was. It could also mean finding missing angles, and we'll talk about that in a little bit. But some of those things require use of the calculator. So I just want to make sure that everybody is comfortable with trig functions in their calculator and that your calculators are in the correct mode. So if you would do me the favor of typing these things into your calculator, I will put my answers on the board and we will confirm that we all have the same answers. If you choose to not do this in your calculator, I cannot help you if your answers are not right later on. And normally, like when you do this on a quiz or a test, I'll ask you to round to the nearest 10,000th place, which is 4 numbers after the decimal. That means to round the 4th number, look at the one right behind it and follow rounding rules. If it's 5 or greater, round that 4th number up. If it's 4 or less, keep that 4th number the same. Okay, so raise your hand if at any point your calculator does not give you these answers. Get these answers, Charlie? I will not, so like on your concept check on Wednesday, on your test next Tuesday, I will not tell you how to do sine, cosine, tangent, or anything else in the calculator. That's your job. You can ask me all those questions today when you're working and come in before and after school, but on a quiz or a test, that's up to you. You should know that by now. Are we clear? Okay. So everybody's okay? Mm-hmm. Note that if you're following rounding rules on that last one, the tangent of 84, in the calculator you probably have 9.5143, and then there's a 6, so the 6 rounds the 3 up to a 4. So if you're following rounding rules, it would be 144 at the 10,000th place.
Okay, so when, like, before when we did that, like the warm-up thing, when you had like sine of 50 equals x over 3 and you had to multiply it by 3, when you put that in the calculator, is that just 3 sine 25?
Yeah, I would do 3 times tangent 25, and I don't think you even have to write the times. I think if you just do 3 tangent 25, you get 1.4. The one thing to be careful of is if you type the like if you were to do tangent of 25 first, does your calculator, the small calculator, also bring up a parenthesis? Yeah. Okay, so if you don't type 3 times tangent 25, then you have to close that parenthesis before you do times 3. Otherwise, it does the tangent of 75. Okay, good. Which probably would have been a better measurement for my ladder. Okay, so it seems like we're all on track there. Now I'm going to talk about reciprocals. Okay, so if you look at your calculator, you have buttons for sine, cosine, tangent, but there are no buttons for cosecant, secant, and cotangent. Now some people's eyes might be drawn right above sine, cosine, and tangent, and you might see those like sine with the -1, cosine with the -1, and tangent with the -1. Do you see that? Those are not reciprocal functions. Okay, let's be very clear about that. Sine with the -1 is not cosecant. Cosine with the -1 is not secant. And tangent with the -1 is not cotangent. What is your question?
What is it?
It's an inverse. So I have an example here with cosecant. It could be any trig ratio. So if we wanted to, we could change this one on the sideboard over here. We could say it's the sine. Okay, so like normally you put an angle in there, right? Like we just did, the sine of 50 degrees. And you got a ratio out. when you were doing your homework last night, you didn't know what the angles were. They were just called thetas, but you could do the ratios like 8 over 11. If you type 8 over 11, you might get a decimal like we got for sine of 50 degrees. So you put in angles and you get out ratios. When you use that second button in the calculator and you get an inverse sign, the sign with the -1, you can't put an angle in there. You put the ratio in there and it works backwards. It tells you what the angle must have been. So like on your homework yesterday where like maybe you saw the sine of theta was 8 over 11. We never knew what theta was. Well, if we use that inverse function, we could do the inverse of 8 over 11 and it would tell us what our angle is. We'll get there with inverse trig functions after section 9.3, but we're not there yet. Okay, so right now we're not using those buttons with the -1. Those are inverses, not reciprocals. So then it's like, how can we do these reciprocals in our calculators? There's got to be a way. So we're going to go off of the definition of a reciprocal. What does reciprocal mean to you?
The opposite.
No,
Flipped. I said opposite yesterday.
Yeah, Kate.
It's flipped.
Right.
Okay, I am very particular. Opposite to me in mathematics would mean change the sign, opposite sign, negative, positive. So when we say reciprocal, we think about flipping that fraction, right? But I get what you're saying when you say opposite. I'm just going to be a stickler there. Okay, so it's flipping the fraction. Okay. Now, if you have the ratio of sides, that's great, right? If you have 8 over 11, you just flip it and make it 11 over 8, and you've got the reciprocal. But in these problems, we won't have ratios of sides. They'll be like the ones on the previous slide where we had like sine of 50, cosine 32, tangent 84. So we're going to go off of this idea. Suppose we have the sine of theta. That's really the sine of theta over what value? Over 1. So if you want to do the cosecant of theta, flip that. So when you want cosecant, you type in 1 divided by sine. Cosecant is 1 divided by sine theta. Secant is 1 divided by cosine theta. And cotangent is 1 divided by tangent theta. Okay, write that down in your notes. You need to know that. Cosecant is 1 divided by sine theta. Cosine is 1 divided, secant is 1 divided by cosine theta. Cotangent is 1 divided by tangent theta. Those relationships also, like next year you might be in Algebra 3 or in pre-calculus, and those relationships are really important later on in the trig chapters. Okay, you make substitutions with those for trig identities. But for right now, we just use them to evaluate in our calculators. Okay, so try, I think I just kept the angles the same. Try these in your calculators. I'll put up my answers and we'll just verify that we're all getting the same answers for reciprocal functions. Make sure that you're getting the same answers when you type into your calculator. If you're not, let me know. You might have to type in a different order. You might have to hit an extra equal sign. You might be in the wrong mode. All calculators should give the same answer. No, that would be sign.
No, and then you put 1 over, right? So
You do 1
over.
divided by
Yeah.
the sine of 50.
So like when I do that, sine.
You haven't done 1 divided by that yet. So, like, this has to be written as
Oh.
1 divided by sine 50. So you gotta type that in your calculator.
Ah, got it.
Don't teach it.
Anybody else have any difficulties? Let me know.
What, Josh?
Okay. Did yours come out? Okay.
Some you have to actually use divided instead of.
So it looks like maybe you. Okay, so the 1 comes first. So you do 1 divided by, and then you put the reciprocal function underneath. Okay, so that's something that I feel like, you know, prior to our concept check, prior to your quiz next Tuesday, you're going to maybe have to spend a little bit of time practicing those reciprocal functions in your calculator because it's not as clear as a straight up button, right? You have to do the reciprocal in the calculator. Okay, so kind of be aware of that. Okay, moving right along. Now let's talk about solving triangles. If the directions simply ask you to solve a triangle, then that would mean find all the missing measurements. So find all the missing angles, all the missing sides, until you really know all 3 angles, all 3 sides. In terms of side lengths, I think we've already now talked about all the ways that we can find sides of triangles. So what are some ways or things, tools that you could use to find the length of a missing side? Pythagorean theorem is probably everybody's favorite, right? Okay, so for side lengths, you can use c squared equals a squared plus b squared. What else could you use to find a missing side length?
Maybe it's like, I don't remember, it's called this, like, y1 minus y2 over x1 minus
That would be slope. Special right triangles? Sure, if you had a special right triangle. And another way to find a missing side length? Trigonometry. That's like our warm-up problem. The ladder against the wall. Okay, so I'm going to say SOHCAHTOA. Okay. In terms of angle measure, what do you know about angles in a triangle? Awesome. They add to 180. And I will say this. At some point, we'll be able to solve for angles using these inverse trig functions, but that won't be until after 9.3 when we get to that. So for right now, we're going to definitely have enough information to be able to just solve for our missing angle right away, based off of the fact that they add up to 180. Okay, so here's a problem. I think I only put one problem like this on your homework because I like word problems way more than this problem, as I'm sure you do too.
Oh yeah.
Always enjoy a word problem.
Right.
Stop.
Okay, but I really do like the word problems. They're more, I like that they're more applicable, and you only have to find one thing usually in a word problem. Now I gotta find all these things.
So funny.
Big change.
Okay, so if you're asked to solve a triangle and they don't give you just like one specific thing to solve for, it means find everything. Like know all the angles and all the sides. So in a triangle, I have 3 angles. Angle A, angle B, and angle C. Sometimes you might already know some of the angles. So we know angle C is 90 degrees. We know angle B is 62 degrees. And for angle A,
28.
how'd you get 28?
I did 90 plus 62 minus 180.
Yeah, subtract those 2 angles from 180. So I'm going to say 180 minus 62 minus 90, or you can just do 90 minus 62 because the 2 acute angles have to be complementary. That's one of your theorems from geometry. But you should get 28. Either way, you work that out. Okay, good. So now we have all 3 angles. We also should be able to name all 3 sides. So in a triangle ABC, then we would have sides A, B, and C. Now, I just want to point something out that maybe wasn't always clear in geometry. So the side A is always opposite of angle A. You should have talked about that. So opposite of angle A is 6. So that's side A. And then opposite of angle B is side B, which we don't know yet. And opposite of angle C is side C. So we normally say that angle C is the right angle so that C squared equals A squared plus B squared. The hypotenuse is C. Okay, so what can we do to find B or C? Lexi.
For B, can we plug in like if we know that angle or side A is 6 and we know that angle B is 62, can't we do it's adjacent and opposite, so O over A, which is tangent. So can't you plug in tangent of 62? And then I don't remember what you do with 6.
Okay, so you're going to use trig, right? We don't have enough information right now to use Pythagorean theorem. I love that idea. So you could go off of angle A or angle B, but Lexi's talking about angle B. And then she says B is the opposite side and C is the adjacent side. Now, if you were looking over here at your 28-degree angle, that would be opposite and adjacent. They would be flip-flopped. But then those things, if you're thinking about SOHCAHTOA, much like our ladder question, opposite and adjacent are TOA. So we set it up. The tangent of 62 is equal to
It's not working ahead. I'm trying to figure out
You have to
what's
multiply
the
6
fraction.
by it.
How do we
And you have
finish?
to multiply it too. Sorry.
Finish the equation.
B over 6.
B over 6. Yeah.
Sorry,
It's just
I-
like writing tangent equals opposite over adjacent, right? That's what you were practicing yesterday. And then to solve for B, multiply both sides by 6. Okay, so we get whatever B equals 6 times tangent 62 is. Quinn, what did you say that was?
It's 11.2842.
Okay, on the side lengths, you can round to the nearest 10. That's fine.
Okay. So
Like when I ask you to do trig ratios in the calculator, like just like sine of 50, that's when you go out to 4. But if you're just evaluating here, the 10th is fine.
Okay, so 11.3.
Okay, great. Okay, now, how would a lot of us then solve for C?
That.
Pythagorean theorem, which is totally fine and I'm okay with. However, just in terms of practicing trig, I'm going to do another trig. Just because. Okay, so what could we use? Let's say we're already working with Lexi. She already labeled. She's looking at 62. 6 is adjacent. That makes C the hypotenuse. Which trig ratio is that? Cosine. I would use the one that was exact, the 6. Okay, you could use 11.3, but I usually stick to the exact one. So then we could create one that says the cosine of 62 is equal to 6 over c. Now, I wanted to show this one because your variable's in the denominator, and that sometimes, people have trouble with. Your geometry teacher might have taught you rules for this, like you just know what the answer's going to look like how to set it up. But I'm just going to talk about the algebra part of it. So if you want to solve for a variable that's in a denominator, get it out of the denominator, right? Multiply both sides by c. So now I have c times the cosine of 62 equal to 6. I want to get c all by itself, so I have to divide by cosine 62.
That's what I said, but I didn't.
And give me a decimal to the nearest tenth.
I got 12.8.
12.8. Now that's the same answer you get with Pythagorean theorem, so it's okay. I just wanted to do another trig function with a variable in the denominator. Yes. If I multiply by 1/6, then I'll be left with 1 over c, which isn't necessarily any easier to solve for. So the key piece here is if your variable is in a denominator, get it out of the denominator. And that would be through multiplication. And that would be true outside of trigonometry. So that would be super helpful algebraically.
Instead of whatever you did, I just divided both sides by 6 because 6 is in the top, so instead of multiplying it, I divided it because I knew the opposite.
And did you get the same answer?
I'm just wondering if it'll always work. Because if 6 is on the bottom, you would multiply it, so I just assumed that if it's on the top, you divide. So I just did
Well,
6
you
divided
can-
by-
Okay, this is also true. If the variable is in the denominator, it's always going to be the number divided by the trig ratio. So that's where I said some people's geometry teachers teach them that. Know this. If the variable is in the denominator, then do the side length divided by the trig function instead of the side length times the trig function. So if that's how you remember it, that's fine. However, I worry about this whole I'm dividing by 6 or multiplying by 1/6. Because that would really mean you would do cosine 62 divided by 6. But then there's that reciprocal on the other side, which really means flip it. So my only concern is make sure that you're getting the right answer on a regular basis and maybe think about that algebraically. Okay. All right. I think this is my last example. Oh, first I have to talk about this. Angle of elevation and angle of depression. I just want to be really clear about this because sometimes people get confused. So angles of elevation and depression come from a horizontal. Never ever is an angle of elevation or an angle of depression going to come from a vertical line. So when you're looking for your right triangle, make sure you either have a top horizontal line or a bottom horizontal line, and that's where you can get angles of depression and angles of elevation. I often like to think about angles of elevation and depression from my line of sight. So this little picture is calling it a horizon line, but I just think about if there was a person looking straight out, to see the object in question, are they looking up or are they looking down? And those represent angles of elevation and depression because normally when you look straight, it's horizontal. And so you can either go up or from your horizontal you can go down. But you're not coming from the vertical because your eyes don't look straight up or down. So angle of depression is right here, angle of elevation right there. a lot of times I think the tricky one is angle of depression. I get a lot of people who draw their right triangle over here. You see it's a rectangle. Okay. And people will call this the angle of depression. Okay, that's not coming from a horizontal line. There's a vertical line. So that is not an angle of depression. Angle of depression is above. You don't have to have a little person there, but like I just like to think about it because that helps me with my horizontal line, where that would be. I'm going to give you time to kind of think about and plan with your groups on our next problem, and then we'll come together and see if we have the same thing. I'm going to be spying on your work as I walk around, as I like to do. Oh, I should probably talk about just real quickly in this example. It says, in physics, you and a partner build and launch a rocket into the air. You can imagine that, right? We as mathematicians, we like to think in simplest terms, so we're not going to take into account any kind of wind or any issues like that. So our rocket is going to go straight up and come down. Okay. You're standing 20 feet from where your partner will launch the rocket. Using a clinometer. Okay, so a clinometer can look at a couple of different ways. This is like a homemade clinometer, which you can make. This is like a straw or a piece of tube. You attach a protractor to it, and then you tie a string with a weight. Just like holds the string down. And then like as you look up and down, like through the straw at whatever object you're looking for, the string will move on the protractor and tell you what your angle of elevation is. So when I'm like right here, it would say, oh, you're looking up at a 70-degree angle. Okay, so it's a way to measure my angle of elevation. So we'd be looking for the rocket, get that in the line of sight of the clinometer, and then we measure that angle of elevation to be 35 degrees. There are other versions of clinometers, or sometimes they're called inclinometers, like an incline. And some of the other versions that maybe you've seen, like in physics class, I think they look like guns. But it's just like you hold it up and then you follow the rocket, and then when you see the rocket reach its max height, you pull this trigger and then it just locks where the angle was, so then you don't have to worry about like reading it. Like, hey, you read this, what's my string at, right? Okay, so you just like pull the trigger and then you see it and you know where it is. Okay. Okay, so we've used a piece of equipment to measure our angle of elevation at 35 degrees. My line of sight is 5 feet above the ground. I want to know, how high did the rocket go? Talk to your group. Oh, do you want to go right now during this word problem? I mean, once we're done with this, then we're free and you can go to the restroom.
Listen, so you're 20 feet over, right? There's your horizontal line. But then there's also a vertical line that is the long rocket.
That's something we're trying to find.
Yeah, and then your hypotenuse is 5 feet, because that's your angle of sight, and you're right here.
So that would be 35. You know that's 35. Yeah, you're right.
But you have to be 20 feet. The total has to be.
Yeah, I don't think 5.
Your line of sight is 5 feet above the ground.
It's above the ground.
So 5 feet. How high it actually goes. But then,
I think the height, okay. I think the height is the leg. That's what I think the height is. The leg. Yeah.
I hear what you're saying.
Eyesight is 5.
This is the line of sight.
We figure out what a 5 is. How 5 is.
Okay, I'm going to interrupt because there's some really good conversations happening. I think we should have one as a whole. I see this triangle or some version of this triangle out there on quite a few papers, which I agree with, right? The angle of elevation is 35 degrees. Here's my rocket. Like that, right? Okay. And then here's me. I'm 20 feet away from the rocket, right? The big question that groups are having is what to do with 5.
It's just
We just add 5 onto your answer.
We'll just add 5 on to our answer. My eyesight, eye level is 5 feet above the ground. So I'm looking out, okay, horizontally. I'm actually not looking straight at the rocket. The rocket is just 20 feet away from me, right? I'm looking 5 feet above. But then I'm using my clinometer to follow that rocket up to its max height. The rocket's going to start on the ground. So when I calculate height, I'm calculating the height from my line of sight through the clinometer. I'll have to add that 5 feet on to the actual height of the rocket. So we could call that other side height. That's fine. But if it's an issue with your line of sight, you have to add the line of sight at the end. What trig ratio would you guys use for this triangle?
tangent.
Tangent, excellent. This is going to be tangent of 35 equals h over 20. Multiply by 20 to the nearest tenth. 14.0. Okay. And then that's the height from my line of sight. So it's actually 19 feet. Yeah. Now, if we're talking about angle of elevation from the ground, then we don't have to worry about adding our eyesight back on. I just wanted to do an example like that because there's an example like that in your homework assignment where they'll talk about your line of sight and how high above the ground it is. Your triangle is like shifted up. So then you need to add that piece back on from the ground. Okay, here's your homework assignment. I think 27 to 32 is just calculator, and then 33 is where maybe that's an error, like find the error problem, and then there's some word problems there. But I'm going to show up the light so you can see the picture better here. I do want to talk real quick about 42 and 44. So they refer to these like an incline and a railway. This number 42 is in Australia. And what it is like this looks kind of like almost like a roller coaster or like a train or something. It's super steep. Have you been?
No, I have friends that were.
Okay, yeah, it's the steepest incline in the world. Okay, so you get on and then you like go down at an angle and you're just kind of like looking around and seeing nature, and there's like a stop where you get off and you can take pictures and then you go down again. Okay, so it's not like a roller coaster like you're going like this. It's just like a straight railway down.
Then how do you get up there?
There's
You probably like take a
it's like there's a big trail on the back side of it that you have to get to go through to get there.
how do you get down a water slide? You walk up the stairs.
That's true.
Okay. There's also this one. I'm going to call it Duquesne. I don't know how you're technically supposed to say that. Anybody? Is that French? I don't know. Do you see this? It kind of looks like a trolley.
Oh,
Okay, and then like there's like this box on the bottom, and then they have like wheels like right here at the bottom of the box and bottom of the trolley, so that keeps it level, so you're not like riding like this. Okay, and then it just goes. This is again just an incline. It's just like this. It goes up the side. I think it's called like Mount Washington or something. It's in Pittsburgh, and it just goes up and down. They built it like back in the late 1800s to like move supplies up the hill, and then later they like people rode it up and down as like neighborhoods got up there, and then they shut it down, and then they reopened it for tourism. So it's literally just like riding, coming down. So it's like an elevator, but it's on a slope. So 2 things to put on your bucket list, places you'd like to go. But you should make right triangles for 42 and 44.
No point in that book on that.